Welcome to this video on how to get an A star in IGCSE Combined Sciences series. This video is for IGCSE Combined Sciences Organic Chemistry, topic C12. We are going to learn topic C12 Organic Chemistry. In organic chemistry, the first topic is C12.1, which is about fuels. We need to know three types of fuels, which is coal, petroleum, and natural gas. All these three types of fuels, boiling point decreases once we move from coal to natural gas. Decrease in the boiling point means natural gas boils at a lower temperature and coal has a very high boiling point or melting point. This refers that coal is solid as compared to petroleum, which is liquid, and the natural gas is gas. The main constituent of the natural gas is methane. Methane is a chemical substance having a formula CH4, and what is methane that we're going to see in a minute. Methane is actually a hydrocarbon having a formula CH4, which is the main constituent of natural gas. Also understand that petroleum, which is a liquid, it is a mixture of different hydrocarbons, and these different hydrocarbons can be separated into useful fractions by fractional distillation. So petroleum is actually a mixture of different hydrocarbons, can be easily separated with the help of a technique called as fractional distillation. Components, different fractions, are separated using distillation techniques. Fraction means different components, and for that purpose a fractionating tower is used, which is a huge vessel in which there is a very high temperature at the bottom, around 350 degrees Celsius, and once we move up towards the top, the temperature decreases. The separation of useful fractions. This could be done with the help of a technique called as fractional distillation. Fractional distillation is a process in which different fractions, means different components, they are separated on the basis of difference in the boiling point of different components or different fractions of the crude oil or petroleum. Petroleum is also called as crude oil. Here you can take a picture. If you're using a MacBook, then take a screenshot, or using your cell phone, and then you can revise from this board, because I'm going to erase this board and you're going to see a new one in a second. The process of fractional distillation can be seen in this beautiful demonstration, in which we can see that there is a tall fractionating tower, and this fractionating tower is the place where the crude oil is introduced from the bottom. So crude oil comes in from the bottom, and over here the temperature rises up till 350 degrees Celsius. Don't worry, as a combined science student, you don't have to memorize these temperatures unless your teacher is forcing you. Maybe sometimes some teachers are teaching IGCSE chemistry and then they keep on teaching the same curriculum for the combined sciences, which I hope should not be the case with you. So the crude oil is placed inside this container, and then this crude oil passes and then it is heated. Then it enters into the fractionating tower, and then all those substances which are having boiling point less than 350, they will not turn into a liquid, and then they will keep on rising in the fractionating tower upwards, where different fractions could be obtained. On the top we can see that we have the petroleum gas. The petroleum gas, also called as the refinery gas. So this is the refinery gas. Its use, you also have to memorize the use. This is used for heating and cooking in houses. So this is used for heating and cooking purposes. This is a bottled gas. Second fraction, which is obtained at a temperature of around 26 to 60 degrees Celsius, that is gasoline fraction. So the gasoline fraction is the one which is used in gasoline or petrol powered cars. Naphtha fraction, it is a feedstock for making many chemicals. So naphtha is basically a feedstock. Feedstock means it is the main chemical, the mother chemical, with the help of which many other secondary chemicals are made. So naphtha is the source of many chemicals in the pharmaceutical industry, in many other industries, in the industries where we are making plastics, cement, and many other chemicals, including paint industry and all the industries which are involved in any type of chemical production. Next fraction is the diesel oil, which is also called as gas oil. So diesel oil or also gas oil, which is used in the diesel powered automotives or automobiles, which are diesel powered engines. So diesel powered engines are in the big vehicles like the trucks and buses. They use engines. Last thing, here on in the diagram you can see the fuel oil. Don't worry about that. The fuel oil is not in your syllabus, so you don't have to worry about that. And same is the case with the lubricating oils. You don't have to worry about them. They are there, but you don't have to learn them because they're not in the syllabus. And the last thing that you need to know, that is the bitumen. The bitumen is the one which is used in constructing roads. So this is used for road surfaces. So for the fractional distillation of crude oil, you have to memorize the first fraction as the refinery gas, second fraction as gasoline, third fraction as naphtha, fourth fraction as diesel, and the fifth fraction as the bitumen. And remember about the paraffin, fuel oil or lubricating oil. These are the one which are not in your syllabus. You don't have to worry about. Next section of the topic, that is 12.2. 12.2 is about homologous series. Homologous series can be defined as the series of alkanes and alkenes as families of compounds with the same general formula and similar chemical properties. So in this definition, there are certain sections which are of prime importance. You have to focus on. These are the series of alkanes and alkenes. What are alkanes and alkenes? These are the types of hydrocarbons, and alkanes and alkenes, as I have said that these are different types of hydrocarbons, means these are the compounds which are made up of carbon and hydrogen only. We're gonna talk about alkanes and alkenes in a minute. So these are the compounds which belong to the same families. So alkanes, all alkanes are just one family and all alkenes are one family. They are having the same general formula and their chemical properties are similar. Not same, they are similar. As I have mentioned that alkanes and alkenes, these are the compounds which we can call as hydrocarbons. These hydrocarbons are just made up of hydrogen and carbon only. So the hydrocarbons are the compounds which contain carbon and hydrogen only. Hydrocarbons are of two different types. These two types are alkanes and alkenes. Focus on the last three alphabets. They are very important because A and E in alkane, it means something. It means the compounds which contain only single covalent bonds, and alkenes means the compounds which contain a double covalent bond, at least one double covalent bond. Alkanes are the compounds which contain single covalent bond, shown by just one straight line. While alkenes are the compounds which contain at least one double covalent bond between carbon atoms. What is meant by the general formula, which is the word used in the definition? General formula refers to a formula which applies to all of the compounds under one particular family. For example, alkanes. So all of the alkanes, they have a general formula of CnH2n plus 2, while the N is the number of carbon atoms present in the particular alkane. On the other hand, the general formula for alkenes is CnH2n. Okay students, over here I will suggest you to take a screenshot, and then I'm going to erase this board, and then we're going to proceed towards 12.3. We are going to learn what is meant by an alkane and what is meant by an alkene. Now we know that these are the members of a series called as homologous series. You need to know about 3 alkanes and 4 alkenes. The first column is for the number of carbon atoms, and the number of carbon atoms determine what type of an alkane or alkene do we have. Remember that if we have one carbon atom that is having a prefix meth, M-E-T-H. So one carbon atom is meth, and then we use the suffix ane or ene depending upon the type of compound we have. If we have all single covalent bonds, then we call it ane, which refers to the compounds alkanes, having a general formula CnH2n plus 2. This formula helps us to find out the number of hydrogen atoms in a particular alkane having a specific number of carbon atoms. On the other hand, alkenes, they have a general formula CnH2n. The first alkane, as the name suggests, it should be methane. ANE means this contains all single covalent bonds. This structure can be drawn by putting the carbon atom in the center and then drawing 4 lines around it. Remember this thing, carbon atom should have 4 lines surrounding it because the valency or the combining capacity of carbon is 4. You have to memorize this thing, that the carbon is having a combining capacity of 4, nitrogen is 3, oxygen is 2, and hydrogen is 1. After completing this table, I'm going to write it down separately in the next board so you can memorize it from there. So methane is not possible because methane cannot exist. The reason methane is not possible because in order for a molecule to be methane, there should be a double bond, and carbon can never make a double bond with hydrogen. Hydrogen's valency is 1, not 2. So methane does not exist. Next group of compounds we're going to talk about containing 2 carbon atoms. If we have 2 carbon atoms, it is having the name suffix starting with ETH, eth. Ethane will be the name given to the compounds which contain all single covalent bonds, while if the covalent bonds are double between 2 carbon atoms, then we will be giving the name ethene. Now, as I have told you, complete the valencies of carbon by putting 3 hydrogen atoms around each carbon in the ethane and 2 hydrogen atoms with each carbon in ethene. Remember this thing, that the carbon should have 4 lines in total. The number of lines should not be 3, 5 or any other number. If you look at this carbon atom, this is having 1 line to this carbon, second line or second covalent bond it makes with the other carbon, third covalent bond it makes with the hydrogen, and fourth covalent bond it also makes with the hydrogen. On the other hand, if you look at the carbon in the ethane or alkane, it has one covalent bond with one hydrogen, second one with another hydrogen, third one with the third hydrogen, and the fourth covalent bond is with the other carbon. Hydrocarbons which contain three carbon atoms, they are having a prefix called as prop, P-R-O-P, and then it could be propane or propene. Propane will be obviously the compound which is containing the single covalent bonds. Applying the formula, the molecular formula of propane is C3H8. How can we get that? If we use the general formula principle, and if we put the C and then N is the number of carbon atoms, as I have told you, N represents the number of carbon atoms present. So if the carbon atoms are 3, then this is C3, and then we can find out the number of hydrogen atoms present over there, and the number of hydrogen atoms would be the 2 multiplied by N plus 2. And this eventually makes up to 8. 2 times N, and N we know that this is 3, so this is 6 plus 2, which gives us the number 8, which I already have written. While drawing the structural formula, we have to draw 3 carbon atoms, and as we had been doing always, we have to complete the valency of carbon by putting 3 hydrogen atoms around each carbon on both the terminals, and the central carbon will receive only 2 hydrogen. That's how the valencies of carbon are fulfilled. On the other hand, for a propane in the next column should have a double bond, and then completing the valencies of carbon by placing 3 hydrogen atoms with the carbon on the right side. The central carbon atom only receives 1 hydrogen. Notice that the central carbon is having 1 covalent bond fulfilled by the carbon on the right side. Second covalent bond is with the hydrogen. Third and fourth covalent bonds with the carbon on the left side. And the carbon on the left side will receive only 2 hydrogen to complete its valencies. The name of this compound is propene. The molecular formula is C3H6. This formula could be obtained by using the general formula of alkenes flashing in the right side rectangle. Now the next hydrocarbon is the one containing 4 carbon atoms, and the compound containing 4 carbon atoms is referred as bute. It is having a prefix bute, and then we can put ANE for all those compounds containing 4 carbon atoms having a single covalent bond, and ENE for the compounds which contain at least 1 double covalent bond. The molecule can be formed by drawing 4 carbon atoms and then completing the structure by completing its valency according to rule of 4 lines with carbon and 1 line with hydrogen, representing covalent bonds. Molecular formula will be C4H10. You can check that using the general formula, which is flashing in the column headings with the alkanes labeling. The name of this compound is butane, while the name of the compound containing 4 carbon atoms with double covalent bond is butene. The general formula could be applied to find out the molecular formula, which is C4H8. Drawing the structure, we can have a double covalent bond between 2 carbon atoms, and then the rest of the covalent bonds are single. Many students get confused and they think that in the alkenes, all of the bonds between the carbon, they should be double covalent bond, and then they do a big mistake by drawing the double bonds between all the carbon atoms, which is actually a wrong structure. So these students end up in drawing a wrong structure. Do not do this mistake. There should be only 1 double covalent bond between any 2 carbon atoms. in the molecule called butene. Now completing the molecular formula for methane, it is CH4. The molecular formula for ethane is C2H6. The name of this compound is ethane. While we have ethene, molecular formula is C2H4. Okay students, I suggest you over here to take a screenshot and then we'll proceed to the next board. We should remember over here that the valency of different elements which are very important in organic chemistry that we have to memorize. I'm going to list them over here. The carbon is having a valency of 4, so each carbon should have 4 lines. On the other hand, the nitrogen is having a valency of 3, so each nitrogen should have 3 lines. While the oxygen has a valency of 2, so each oxygen should have 2 lines only, and the hydrogen is having a valency of 1, should have only 1 line. Now we are going to talk about the properties, chemical properties of alkanes, and remember that alkanes are generally unreactive. Why are they unreactive? Because they do not contain any double covalent bond, so they are unable to react as rigorously as the alkenes can. So properties of alkanes, we only have to know the properties of methane as an example according to the syllabus. So methane, generally it is unreactive, it does not react or it does not show many of the chemical reactions except one type of chemical reaction called as combustion. Combustion is a type of reaction which is commonly known as burning. We can also say that combustion means heating in the presence of oxygen. So remember that whenever the methane is going to react with oxygen and once you heat it, the reaction would end up always in the formation of carbon dioxide and water. In order to balance, we have to put a 2 before water and we have to put a 2 before oxygen. Now the equation is balanced. So we have to heat this in order for the process of combustion to take place. So combustion always produces carbon dioxide and water. Always write down a balanced chemical equation. Also learn that every hydrocarbon, whenever any hydrocarbon combines with oxygen during combustion, every hydrocarbon is going to generate carbon dioxide and water. The result will be the same as what we have seen for methane. So all hydrocarbons, whenever they combine with oxygen, the result will be always the production of water and carbon dioxide. You can pause the video here and you can take a screenshot, and then we are gonna move ahead towards alkenes. Alkenes are the compounds, as we already have discussed. These are the compounds which are called as unsaturated compounds. Unsaturated compound mean this term is used for all those compounds which contain a double covalent bond. So all alkenes contain a double covalent bond. They are not fully saturated with hydrogen. They do not contain the maximum number of possible hydrogen for any specific number of carbon atoms. That's why they are called as unsaturated compounds. So any compound which contain double covalent bond are called as unsaturated compounds. So alkanes can undergo a process called as cracking. As a result of cracking, the alkanes can make alkenes. Cracking is of two types. The first type is called as catalytic cracking, in which a catalyst used. The catalytic cracking results in the formation of an alkene of the same size. So if we have, let's say, C4H10, which is a butane, as a result of cracking, this is going to turn into butene, and that butene will be having a formula of C4H8. So we have obtained a hydrocarbon of the same number of carbon atoms, but 2 less hydrogen atoms, and these hydrogen atoms, they are released as a gas from here. On the other hand, there's another type of cracking which is called as thermal cracking. As a result of thermal cracking, the results are slightly different. The thermal cracking results in the formation of a smaller alkane as well as alkene. No hydrogen is released during this process. So we will get C2H6, which is an alkane. The name of this alkane is ethane, along with the production of C2H4, which is ethene. So a butane is cracked into an ethane and ethene. This is about the recognition of saturated and unsaturated hydrocarbons. So basically, it is the test for unsaturation. So how can we find out that a compound is saturated or unsaturated? Testing for saturated and unsaturated hydrocarbons. There could be 2 ways by which this could be done. The first method is from molecular structures. Obviously, now we know that if we are looking at a molecular structure and if we cannot identify any double covalent bond in the molecule, so this is considered to be a saturated compound. So the saturated compound will be the compound having all bonds single. On the other hand, if we look at a molecule and that molecule is showing the presence of a double covalent bond, this indicates that the compound is unsaturated. So the presence of double covalent bond indicates that the molecule is unsaturated. Another way with the help of which we can find out whether a molecule is saturated or unsaturated, that is the use of the aqueous bromine, simply called as bromine water. So the reaction with aqueous bromine, so mixing the bromine water with a solution, if results in the decolorization of the orange color of bromine, that suggests the presence of unsaturation, because only unsaturated compounds can react with bromine. Saturated compounds do not react with bromine. So we are adding a hydrocarbon. If the bromine is decolorized, this is indicating the presence of double bond in the hydrocarbon, and this is a test for unsaturation. This is due to the fact that if there is a double bond, one of the 2 bonds break and they create an opening for the bromine atom to attach to each carbon. As a result of this reaction, we are going to get a compound which is having bromine added to it. We can see that the bromine is added to the unsaturated compound because of the breakdown of the one of the 2 bonds between carbon because of the unsaturation. If this unsaturation is not there, if there is no double bond, this bond is not going to break. So bromine actually causes the bond to break. This breaking of one of the 2 covalent bonds between 2 carbon atoms creates an opening for the bromine molecule to add, while the compounds containing single covalent bond, they do not get a chance to get added. While on the other hand, if there is a saturated compound, it doesn't contain a double covalent bond, and the single covalent bond is stronger, it does not break down as easily as the double bond. The whole double bond does not break, only one single covalent bond breaks, creating an opening for the bromine to come and react in. That's why the orange color of the bromine disappears. Next subtopic is the last one for organic chemistry. This is 12.4.5. In the 12.4.5, we're going to talk about addition polymerization. There is another type of polymerization, but that is not in the syllabus of coordinated science. In the addition polymerization, no removal of water takes place and not any substance is added to the hydrocarbon. It is simply, as we have seen, that one of the two covalent bonds have a tendency to break. That's how one of the two bonds between the carbon atoms, they just break, creating an opening for the polymerization. We can see that this type of polymerization can take place between two or more than two ethene molecules. So if I draw an ethene molecule, this is an ethene. Two carbon atoms are having double covalent bond between them. If there is another ethene molecule, this ethene molecule also has a double covalent bond. During addition polymerization, one of the two bonds between the carbon atoms, they are going to break, as a result of which there is the process of polymerization take place. The word polymerization came from a combination of two words. Poly means many and mer means units. So actually many units, many similar units, many identical units, for example in this case many ethene molecules, they are going to combine to each other and then they are going to make a long chain of hydrocarbons, and we're going to see it in this diagram. So we can see that one of the two bonds between carbon atoms is broken and then one of the valency of each terminal carbon is now free. So these carbon atoms, they are going to link to each other, and then it will result in the formation of a very long molecule. This is just a demonstration of two units combining, but in reality not just two units combine. So how do we show a reaction, a chemical reaction, in the form of a chemical equation? Sometimes it is shown like there is an ethene and we are showing that there are n number of ethene molecules. They combine together as a result of polymerization, and then we draw a big bracket completing the hydrogen atoms, closing the bracket and putting N at the base. So the compound or the polymer which is formed is called as polyethene, commonly known as polyethylene. So over here we can see that this molecule or the ethene, that is called as a monomer. The word mono means one and mer means unit. So the monomer of this polymer is ethene. So after the name of the monomer, the polymer is called polyethene, means many ethenes combined together. So this is called as addition polymerization, and this is the end of the whole topic of organic chemistry, C12 of combined sciences. I hope that you have understood everything related to organic chemistry. This is a comparatively harder topic, longer topic. In approximately half an hour is a big achievement which you have achieved. So I congratulate you. Don't forget to do the practice of the past paper questions. Keep revising and doing the practice of drawing all the organic structures. All the best and stay tuned. Please don't forget to subscribe the channel. Press the bell icon for the latest updates and drop a comment or any question in the comment section below. Thanks a ton for watching. Hope to see you again soon.